What if I told you that a ghost from a time before the Earth existed is currently passing through our solar system? This isn't a metaphor. We have tracked it, we have measured it, and as of this moment, it is behaving in ways that defy our most fundamental understanding of the universe. For 8 days, it hid behind the sun, performing an unseen maneuver in complete privacy. Now it has emerged, and the data we are getting back is making the hairs on the back of our necks stand up. The official story is that it's just a comet, albeit a strange one. But the pieces don't fit. Data is missing, powerful observatories have gone silent, and the anomalies are piling up to a statistical impossibility. This isn't just a story about a rock in space. This is a story about a mystery that could rewrite everything we know about our place in the cosmos. Let's look at the evidence together, and you can decide for yourself. Imagine a cosmic entity, the size of a mountain, hurtling through the void for an unimaginable 10 billion years. Its journey began in a universe that our own sun would not know for another 5 billion years. This object, which we have designated 3IATLAS, has drifted through the cold, silent darkness between stars, a solitary traveler on an eternal voyage. In late October of 2025, it finally approached its first star in all that time, our own. As it neared its closest point to the sun, a moment astronomers call perihelion, something extraordinary happened. It should have been a predictable event. The sun's heat should have caused the ice on its surface to sublimate, creating a gentle, gradual brightening and a tail of gas and dust pointing away from the star. That is what comets do. It's basic physics. But 3IATLAS broke the rules. In the final hours before it swung behind the sun and out of our view, it began to brighten with a ferocity we have never witnessed. It wasn't a gradual warming. It was an aggressive, exponential surge of light. Its glow intensified at a rate that made seasoned astronomers question their instruments. And then there was the color. The light it was emitting was a deep, impossible blue. To understand how profoundly strange this is, you need to know a little about color and temperature. Think of a blacksmith's forge. As metal heats, it first glows a dull red, then a brighter orange, then yellow, and finally a brilliant white, or even blue-white. The color of light is a direct indicator of its temperature. Our sun's surface, at about 5,800 Kelvin, glows with a yellowish-white light. For 3IATLAS to appear bluer than the sun, the source of its light had to be significantly hotter than the sun's own surface. This object, which should have been a frozen relic, was somehow generating temperatures that dwarfed the star it was orbiting. It's like finding a block of ice that is burning hotter than a blast furnace. It simply shouldn't be possible. And then, it vanished. On October 29th, it slipped behind the sun, entering a cone of silence where none of our ground-based telescopes could follow. For 8 long days, the cosmic ghost performed its closest maneuver in complete and total privacy. Our most powerful eyes were blind. What happened in that hidden arena? Did it recharge? Did it change course? Did it deploy something? We had no way of knowing. The entire astronomical community held its collective breath, waiting. When the Punch satellite constellation captured the first images of it re-emerging on October 30th, there was a sense of relief mixed with profound unease. The public data, released by NASA's automated tracking systems, showed that the comet had maintained its expected trajectory. No deviation, no sudden turn towards Earth. It had looped around the sun exactly as gravity predicted it should. But that's where the public story ends, and the deeper mystery begins. Because behind the scenes, information was being concealed. We now know that NASA's Mars Reconnaissance Orbiter, MRO, a sophisticated satellite with a high-resolution camera, was perfectly positioned to capture detailed images of 3IATLAS when it passed within a mere 30 million kilometers of Mars on October 2nd. These images could potentially show us the surface of this object in unprecedented detail. Are there structures? Is it a solid body or a collection of rubble? Harvard astrophysicist Avi Loeb, a vocal proponent of investigating these anomalies, formally requested access to these images. The response from NASA? Silence. To this day, those potentially world-changing images remain unreleased. And NASA isn't the only one holding back. China's Purple Mountain Observatory, one of the world's premier tracking facilities, had been monitoring 3IATLAS with an intense focus throughout August and September. They were publishing their data openly, contributing to the global understanding of the object's path. Then, immediately after the Mars flyby, the very same time the MRO took its hidden images, the Chinese data stream stopped, abruptly. Their official reason was a series of scheduling conflicts with lunar missions. The timing is more than just curious, it's deeply suspicious. Two of the world's leading space agencies, with the best views of this object at a critical moment, simultaneously go quiet. This isn't just about a puzzle with missing pieces. This feels like a puzzle where someone is actively hiding the pieces from us. What did they see? What is in those images that warrants this level of secrecy? The event behind the sun was not just a celestial passage. It has become an event horizon of information, beyond which we are not being allowed to see. To even begin to grasp the enigma of 3IATLAS, we have to recalibrate our sense of time. Our entire solar system, with the Sun, the Earth, and everything we have ever known, is about 4.5 billion years old. The data, based on its trajectory and composition, suggests that 3IATLAS is 10 billion years old. Let that number sink in. This object is more than twice as old as our world. It's a visitor not just from another star system, but from another era of the universe. To put that into perspective, let's compress the entire 13.8 billion-year history of the universe into a single calendar year. The Big Bang happens at the stroke of midnight on January 1st. The first stars and galaxies begin to form in late January and February. According to the data, 3IATLAS would have formed around late May of this cosmic year. Our Sun and the Earth? They don't even begin to form until early September. The entirety of recorded human history flashes by in the last 14 seconds before midnight on December 31st. This object is a true primordial relic. It was born into a universe that was fundamentally different from the one we inhabit today. The cosmos was younger, smaller, more violent. The first generation of massive, brilliant blue stars had lived their short, spectacular lives and exploded as supernovae, seeding the void with the first heavy elements. Galaxies were still crashing into each other in chaotic mergers, forging the grand spiral structures we see today. Somewhere in that ancient, turbulent cosmos, 3IATLAS took shape. And this is where the central paradox lies. What kind of object can survive for 10 billion years of this? Natural comets, the kind born in our own solar system, are fragile. We call them dirty snowballs for a reason. They are loose agglomerations of ice, dust, and rock, held together by weak gravitational and chemical bonds. They are cosmic survivors on a very limited timescale. Over billions of years, they face a gauntlet of destructive forces. Every pass near a star exposes them to immense gravitational tides that can tear them apart. They are constantly bombarded by cosmic rays, high-energy particles that degrade their surfaces and weaken their internal structure. Micrometeorite impacts, even tiny ones, act like sandblasting over geologic time, eroding them away particle by particle. Yet here is 3IATLAS. It has likely passed through countless star systems, survived the radiation of multiple stellar environments, and endured the vast, empty loneliness of interstellar space for a period of time our minds can barely comprehend. And it has arrived not as a battered, crumbling remnant, but as an intact, functional object. It is actively venting gas, putting on a display as if it were a fresh comet just dislodged from the Oort cloud, not a 10-billion-year-old wanderer. Its very existence is a defiant contradiction to everything we know about cometary physics and the relentless entropy of the universe. It shouldn't be here. It shouldn't exist. and yet it does. When you encounter a single anomaly in science, you might dismiss it as a measurement error or a statistical fluke. When you encounter a half dozen or more, all pointing in the same strange direction, you must start to consider that you are not looking at a fluke, but a pattern. The case for 3IATLAS being something other than a natural object is built on a foundation of interlocking improbabilities. If you were to multiply the odds of each of these anomalies occurring by chance, you arrive at a number so vanishingly small, it becomes statistically meaningless, less than 1 part in 10 quadrillion. To put that in perspective, the odds of winning the Powerball lottery jackpot are about 1 in 292 million. You would have to win the Powerball jackpot 34 million times in a row to match the odds of 3IATLAS being a natural coincidence. Let's examine the evidence, exhibit by exhibit. Anomaly 1. The trajectory. Interstellar objects should, by all rights, come at us from random directions, like raindrops in a storm. Yet 3IATLAS's path is aligned almost perfectly with the ecliptic plane, the flat disk where all of our planets orbit, to within 5 degrees. The statistical probability of this happening by chance is a mere 0.2%, or 1 in 500. But it gets weirder. Its arrival time was so perfectly calibrated that its trajectory brought it within tens of millions of kilometers of Mars, Venus, and Jupiter, and positioned it to be directly behind the Sun, hidden from Earth, during its most active perihelion phase. Anomaly 2. The sunward jet. This is a true mind-bender. Between July and August 2025, multiple observatories, including the Hubble Space Telescope, documented something that should be physically impossible. 3IATLAS was venting a significant plume of material directly toward the Sun. Imagine a sailboat. The wind from the Sun, solar wind and radiation pressure, always pushes the sail, the comet's tail, away from it. The tail always, without exception, points away from the heat source. Yet 3IATLAS had what astronomers are calling an anti-tail, a jet that defied this fundamental law for weeks on end. This wasn't an optical illusion. It was confirmed by multiple telescopes from different viewing angles. It was as if this object had a propulsion system capable of overcoming the Sun's own force. Then, sometime in October, right around the Mars flyby and just before it went behind the Sun, the anomaly corrected itself. The sunward jet disappeared, and the comet's plume began to behave normally, venting away from the Sun as expected. What kind of natural mechanism can turn on, violate the laws of physics for months, and then turn off? Anomaly 3. The composition. When astronomers used spectroscopy to analyze the chemical signature of the gas cloud around 3IATLAS, they found something that made them check their data again and again. They found nickel, and lots of it, being vented at a steady rate of 4 grams per second. While some comets have trace metals, the problem was what they didn't find: iron. In nature, iron and nickel are forged together in the hearts of dying stars in very specific, well-understood ratios. Iron always dominates. To find this much nickel with almost no corresponding iron is like finding smoke without a fire. The nickel-to-iron ratio observed in the comet's plume doesn't match natural stellar chemistry. It perfectly matches the composition of industrial nickel alloys, the kind of materials we humans create for high-strength, high-temperature applications. Furthermore, the ratio of nickel to cyanide was orders of magnitude higher than any comet ever studied. The probability of these ratios occurring naturally is less than 1%. Anomaly 4. The water content. Comets are defined by their ice. They are primarily made of water, typically 70% to 80% by mass. Water is the volatile engine that drives their activity. When heated by the Sun, this water sublimates into vapor, creating the coma and tail. 3IATLAS has an observed water content of just 4%. 4%. It is an incredibly dry, rocky object that is somehow outgassing with the ferocity of a pristine ice ball. What kind of comet barely contains water? Anomaly 5 and 6. The light and the echo. When sunlight bounces off an object, it becomes polarized. The specific signature of this polarization tells us about the texture and composition of the object's surface. 3IATLAS exhibits a type of extreme negative polarization never seen before in any comet, asteroid, or planetary body in our solar system. The measurement is so far outside the normal range that once again, the statistical likelihood is less than 1%. And finally, there's the eerie connection to one of astronomy's greatest mysteries. In 1977, the Big Ear radio telescope detected a powerful 72-second narrowband radio signal from space. The signal was so striking and appeared so artificial that astronomer Jerry Ehman wrote, "Wow," on the data printout. The source was never found. When you trace the trajectory of 3IATLAS back through interstellar space, you find that it arrived from a direction in the sky that aligns with the WOW signal's origin point to within 9 degrees. Another coincidence? Perhaps. But when you stack coincidence upon coincidence upon coincidence, there comes a point where an intelligent person must ask, is there a better explanation? Let's return to the climax of the story. The moments during perihelion when 3IATLAS passed through the sun's furnace. What happened there elevated this object from merely strange to physically inexplicable. This wasn't just observed by one instrument. It was a cosmic event witnessed by a fleet of our most advanced solar observatories, each acting as an independent, corroborating witness. The Stereo A spacecraft, the SOHO Solar Observatory, and the newest GOES-19 weather satellite all captured the same phenomenon. As 3IATLAS got closer to the sun, it didn't just get brighter. Its brightness exploded. The scientific papers describe this with a chillingly precise term. The brightness increased inversely with distance to the power of 7.5. In plain language, this means that for every step it took closer to the sun, the light it emitted grew exponentially more powerful, a relationship far, far steeper than any natural comet has ever displayed. Fresh comets from our own Oort cloud, loaded with pristine ice, should be the most active. Yet this ancient water-depleted object was outshining them all, blazing with an impossible intensity. The halo of gas and dust around its nucleus, its coma, swelled to an unbelievable size, 300,000 kilometers across. That is almost the distance from the Earth to the Moon. This wasn't a typical, fuzzy, cometary coma. High-resolution images from the coronagraphs showed it had structure, layers, and a degree of organization that was deeply unsettling. But the true smoking gun, the piece of data that breaks our models of physics, was its color. As we discussed, the light was intensely blue, indicating a temperature far hotter than the sun's surface. This observation rules out the two primary ways a comet can shine. It can't be reflected sunlight because that would have the same color as the sun, or be slightly reddened by dust. It can't be thermal emission, the glow from its own heat, because its surface, even at perihelion, should be hundreds of degrees colder than the sun. This leaves only one possibility. The light was being emitted. Something on or inside 3IATLAS was generating its own light, creating temperatures that simply do not occur on the surface of natural comets. Could it be fluorescence, where solar UV radiation excites gas molecules, causing them to glow? While some cometary gases do fluoresce, it produces a faint, ethereal glow, not a brilliant light source that dominates the object's entire spectrum and outshines the sun's own reflected light. The observed blue shift was simply too powerful, too pronounced for fluorescence to be the answer. The data forces us into a corner, leaving us with a conclusion that is as fantastic as it is logical. The observations are consistent with 3IATLAS operating an internal power source, an engine, a reactor, some form of technology that was either activated by the close solar pass or was using the sun's immense energy to recharge. I'm not stating this is definitively the case. I'm stating that this hypothesis, as extraordinary as it sounds, is the one that best fits the observed data. We are either witnessing a completely new, unknown type of natural astrophysical phenomenon, or we are looking at a machine. For a moment, let's step away from trying to force this object into the box of a natural comet and entertain a different hypothesis. What if it isn't a comet at all? What if 3IATLAS is a piece of technology? Suddenly, the anomalies are no longer contradictions. They become design features. The pieces of the puzzle click into place with an unnerving elegance. Its 10-billion-year survival is no longer a paradox of fragility. It's a testament to incredible, almost unimaginable, engineering. A probe designed for an eons-long journey would need to be built with extreme durability, perhaps with self-repair capabilities to withstand the ravages of interstellar travel. Its structural integrity, its refusal to break apart under the sun's tidal forces, speaks not of loosely bound rubble, but of solid, manufactured construction. The impossible blue light, the internal heat source, is no longer a physical mystery. It's the signature of its power plant. A perihelion pass would be the perfect opportunity for such a probe to refuel. Imagine a craft designed with vast absorbing surfaces, using the close flyby to soak up stellar radiation and convert it into usable energy, storing it for the long, cold journey ahead. The exponential brightening and intense heat would be the visible signs of this recharging cycle, like seeing a factory power up its main furnace. The bizarre chemical composition, the industrial nickel-to-iron ratio, makes perfect sense if the material being vented isn't primordial rock, but rather processed material. It could be exhaust from a propulsion system, spent coolant from the reactor, or even the shedding of an ablative heat shield designed to protect the craft during its fiery solar encounter. The 40 metric tons of nickel it vented isn't much, when you consider the object's total mass is 30 billion kilograms. It's a tiny fraction, consistent with a system purge. Its trajectory, that statistically impossible alignment with our solar system's planets, ceases to be a coincidence and becomes a deliberate flight path. A probe designed to gather data would want to observe multiple worlds on a single pass. The path it took gave it optimal views of Mars, Venus, and Jupiter. The fact that it didn't alter its course to get a closer look at Earth isn't necessarily evidence against this. Perhaps its mission priority was the star, not the planets. Or perhaps, more chillingly, it did observe us from a distance and determined we weren't worth a closer look, or that its mission was one of passive observation, not contact. A slight course correction centuries or millennia ago could have set it on this precise, efficient path, requiring no further energy expenditure. It would simply coast, observe, and record. When you look at it through this lens, 3IATLAS stops being a weird comet. It starts to look like a highly advanced, ancient, and profoundly patient machine, following a program set in motion by minds that may have vanished from the universe billions of years ago. We are talking about a civilization that could build objects the size of mountains, accelerate them to interstellar speeds, and design them to remain functional across geological time. The scale of such an achievement is so far beyond our own capabilities that it is difficult to even comprehend. But the data, in its cold, hard strangeness, invites us to try. The mystery of 3IATLAS has now ignited one of the most significant and coordinated observation campaigns in the history of astronomy. This is no longer a routine tracking exercise. It is a global investigation. Starting in late November 2025 and continuing through early 2026, every major observatory on and off this planet will turn its attention to this singular object. It's a detective story being played out on a cosmic scale, and we are all living through it in real time. On December 19th, 3IATLAS will reach its closest point to Earth. While still a vast 269 million kilometers away, This will be our best opportunity to study it. The Hubble Space Telescope, which gave us the first stunning images of the sunward jet, will observe it again. This time, scientists will be comparing the new images to the old ones, looking for changes. Has the surface altered? Have new vents opened up? Is the mysterious jet returning? The James Webb Space Telescope, JWST, our most powerful eye in the cosmos, will join the hunt. Webb sees the universe in infrared, the language of heat. This makes it the perfect instrument to search for the technological smoking gun, an anomalous heat signature. If 3IATLAS has an internal power source, an engine or a reactor, it must generate waste heat. Webb will map the temperature across its surface, looking for hot spots that don't match the patterns of solar heating. A discovery of such a hotspot would be almost definitive proof of technology. Simultaneously, the world's most powerful radio telescopes, from the Very Large Array in New Mexico to the International Square Kilometer Array Project, will be listening. At Avi Loeb's urging, the SETI, Search for Extraterrestrial Intelligence Institute, is dedicating instrument time to monitor 3IATLAS for any electromagnetic emissions. They are searching for any signal that is not random noise, a narrow-band transmission, a repeating pattern, a data burst. If the probe is communicating with its home system, or even just using active sensors like radar to scan our solar system, we might be able to detect it. So far, there has only been silence. The data from the European Space Agency's JUICE spacecraft, which is on its own journey to Jupiter, will be crucial. It will observe 3IATLAS twice in November, and while it's too far for detailed images, its spectrometers will provide another vital analysis of the object's composition. We won't get that data until February 2026 due to the slow transmission rates from deep space, but it will be another key piece of the puzzle. And hanging over all of this is the political intrigue. Why won't NASA release the Mars Reconnaissance Orbiter images? Why did China's data stream go dark? U.S. Congresswoman Anna Paulina Luna has publicly stated she is working to get those MRO images declassified, suggesting that the pressure is building. Are the world's governments engaged in a silent race to understand this object, knowing that whoever confirms its true nature will hold the single greatest secret in human history? The coming weeks and months will be a tense and exciting time. Every new observation, every data point, could be the one that solves the mystery. We are no longer passive observers. We are watchers, actively interrogating a visitor from the stars, waiting for it to reveal its truth. It is tempting to view 3IATLAS as a singular, once-in-a-lifetime event. But the truth may be far more profound. It is the third confirmed interstellar object we have detected in just 8 years, following the bizarre, cigar-shaped Oumuamua in 2017 and the relatively normal comet Borisov in 2019. The fact that we have found 3 so quickly with our current limited technology implies that our solar system is being visited by such objects far more frequently than we ever imagined. Statistical models suggest that for every one we spot, thousands more pass through completely undetected. Our little corner of the galaxy, it seems, has a steady stream of interstellar traffic. What makes this truly fascinating is the emerging pattern. Borisov was normal. It behaved exactly as we would expect an interstellar comet to behave. But Oumuamua was deeply weird, accelerating away from the Sun in a way that defied gravity, with no visible outgassing to explain it. And now we have 3IATLAS, which is weird on a whole other level. 2 out of the 3 interstellar visitors we have closely studied have been profound anomalies. If you were a biologist sampling a new ecosystem and 2 out of your first 3 specimens were unlike any known form of life, you wouldn't just call them weird fish. You would have to seriously entertain the possibility that you have discovered something entirely new. This is the foundation of Avi Loeb's provocative but testable hypothesis. What if a certain percentage of the objects drifting between the stars are not natural? What if they are artificial? Think of the history of the galaxy. Over 13 billion years, millions, perhaps billions, of technological civilizations could have emerged, flourished, and vanished. If even a small fraction of them launched interstellar probes for exploration, for colonization, for simple data gathering, the galaxy by now could be saturated with them. Like plastic bottles in Earth's oceans, the number of these artificial objects could be immense, a silent testament to countless forgotten creators. The probes of a long-dead civilization would just keep going, following their final programmed instructions for eternity. This idea radically reframes the Fermi paradox, which asks, if the universe is full of life, where is everybody? The answer might be that they are here, or at least their artifacts are. We just haven't been looking for the right signs. We've been listening for radio signals, but maybe the calling cards of advanced intelligence aren't messages, but physical objects. Silent, patient, durable probes, masquerading as asteroids and comets. The story of 3IATLAS is therefore not just about one object. It's about a potential paradigm shift in our search for extraterrestrial intelligence. It suggests that the evidence might not be in faint signals from distant stars, but in the strange rocks passing through our own backyard. As 3IATLAS continues its journey, moving away from our sun at 210,000 kilometers per hour, it leaves us with more questions than answers. It is a cosmic messenger, but the message is written in a language we don't yet understand. By February 2026, when all the data from this observation campaign is in, we will likely have a scientific consensus. The most probable outcome is that we will find a natural, if highly unusual, explanation for its behavior. Perhaps it is a rare type of planetary fragment with exotic chemistry that we have never encountered before. Science, after all, generally favors the mundane explanation over the extraordinary one. But what if it doesn't? What if the anomalies remain, defiant and unexplained? What if the JWST finds a hotspot, or Hubble images something geometric on its surface? The confirmation that 3IATLAS is artificial would be the most profound discovery in human history. It would be the definitive end of our cosmic loneliness. It would change our science, our religions, our philosophies, and our entire perception of our place in the universe. Regardless of the final verdict, the journey of 3IATLAS has already taught us invaluable lessons that we can apply to our own lives. First, it teaches us the importance of paying attention to the anomalies. In science and in life, it is at the edges of our understanding, where things don't fit our expectations, that true discovery happens. When a piece of data doesn't fit the narrative, don't discard it. Interrogate it. That is where progress lies. Second, it reminds us to hold two competing ideas in our minds at once: profound skepticism and radical openness. We must demand extraordinary evidence for extraordinary claims, but we must also be open to the possibility that the universe is far stranger and more wonderful than our current models can account for. Finally, this story is a powerful lesson in perspective. We live our daily lives consumed by small worries and immediate concerns. To look up at an object that began its journey before our planet was even formed is to be reminded of the incredible scale of time and space. It invites us to be more curious, more humble, and more in awe of the grand unfolding mystery of which we are a small but precious part. So I ask you, what do you hope the answer is? Would you be comforted or terrified to learn that we are not alone? What do you think would change in your own life and in the world the day after such a discovery? There is no right answer, but the question itself is what matters. As we continue to watch the skies, remember that we are living in a golden age of discovery. We are the first generation of humans who can genuinely investigate these questions with the tools of science. Whether 3IATLAS is a ghost ship from a lost civilization or a stunning natural wonder, it is a gift. It is a reminder to keep asking, to keep exploring, and to never lose our sense of wonder. Thank you for joining me on this journey, And if you enjoyed this deep dive into one of the universe's greatest mysteries, please consider subscribing to the channel. We have many more journeys to take together.